In today's episode, you will learn how to make your own IoT-based home or office security system using Nodemcu, ESP8266 Wi-Fi module, PIR sensor, infrared sensor, and blink application. Each time an intruder is detected, a notification message is sent to the blink application. This is a real-time IoT-based security system. With the help of Nodemcu ESP8266 Wi-Fi module, the PIR sensor and IR sensor can be monitored from anywhere around the world. In this episode, we will cover number 1, complete circuit diagram explanation, number 2, interfacing, number 3, Nodemcu programming, and finally number 4, testing. Without any further delay, let's get started. The components and tools used in this project can be purchased from Amazon. The components purchase links are given in the description. This schematic is designed in Ksoft Eagle 9.1.0 version. If you want to learn how to make a schematic and PCB, then watch my tutorial. The link is given in the description. As you can see in this project, 2 power supplies are used. This power supply is used to power up the Nodemcu ESP8266 Wi-Fi module, while this power supply is used to power up the PIR sensor. The voltage required to power up the PIR sensor is from 5 to 20 volts, as the PIR sensor module has a 3.3 volt voltage regulator. So the PIR sensor module cannot be powered up using 3.3 volts from the Nodemcu module. So that's why I'm using a separate 5 volt regulated power supply for the PIR sensor. Both the power supplies are exactly the same and can be powered up using a single 12 volt adapter. J1 is a female power jack, and this is where we connect a 12 volt adapter, battery, or a solar panel. 2 470 microfarad capacitors are connected at the input and output sides of the 7805 voltage regulator. A 330 ohm resistor is connected in series with a 2.5 volt LED. This is a current limiting resistor. The output of the voltage regulator is connected with the VN pin of the Nodemcu ESP8266 Wi-Fi module, and the ground of the power supply is also connected with the ground of the Nodemcu module. This power supply is also exactly the same. The out pin of the IR sensor is connected with the digital pin D1. VCC pin of the infrared sensor is connected with the 3 volt pin of the Nodemcu module, while the ground is connected with the ground. The VCC pin of the PIR sensor is connected with the output of the regulated power supply. The out pin is connected with the digital pin D0, and the ground pin is connected with the ground. This is the final board after soldering. The PCB designing, online order placement, and soldering is already explained in my previous tutorial. The link is given in the description. This is the IR sensor that I'm going to use in this project. As you can see, all the pins are clearly labeled with out, ground, and VCC. The white wire is connected with the out pin of the IR sensor, and this will be connected with the digital pin D1 of the Nodemcu module. The brown wire is connected with the ground pin of the IR sensor, and this will be connected with the ground of the Nodemcu module. The red wire, which is the VCC wire, will be connected with the 3.3 volt pin of the Nodemcu module. This is the PIR sensor. The leftmost pin is the VCC, the middle one is the out, while the rightmost pin is the ground. I have a very detailed getting started tutorial on the PIR sensor, so for the basic understanding you should watch that tutorial which explains everything. This is the regulated 5 volts power supply based on the LM7805 voltage regulator. This power supply will be used to power up the PIR sensor. The orange wire is the 5 volt wire, while the blue wire is the ground wire. All the components are interfaced as per the circuit diagram already explained. As you can see, the output of this power supply is connected with the VCC pin of the PIR sensor, while the out pin is connected with the D0 and ground is connected with the ground. The red wire is connected with the 3.3 volt pin of the Nodemcu module. The brown wire is connected with the ground, while the out pin of the IR sensor is connected with the D1 pin of the Nodemcu module. One more thing, make sure you connect the ground of this power supply with the ground of the Nodemcu module. So that's all about the interfacing. Now my friend Selena will explain how to make a Blink application.
Open the Blink application. Click on the new project and enter the project name as IoT Security System. Click on the Choose Device and select Nodemcu. Make sure you set the connection type to Wi-Fi. Finally, click on the Create button. An authentication token will be sent on your email ID, which will be then used in the programming. Simply copy and paste it in the programming. Now click on the screen and search for the LED. Click again on the screen and add another LED. Click again on the screen and this time search for the terminal widget and add it. Finally, add a notification widget. Click on the first LED, set the name and select the virtual pin V2. Now click on the second LED, set the name and select retro pin V3. Finally, click on the terminal widget, set the name and select retro pin V4. Set add new line to yes and input line to off. So that's all about the application designing. Now let's have a look at the Nodemcu programming.
Before you start the programming, first of all, make sure that you download these libraries from our website. You can find link in the description. This is the authentication number which was sent via email. This is the name of the Wi-Fi router and this is the password. This is the same function I have been using in all of my IoT based projects. The PIR sensor is connected with the digital pin D0 of the Nodemcu module and the infrared sensor is connected with the digital pin D1. Unlike the Arduino and Mega, the Nodemcu ESP826655 module also has at least two functions, which are the wide setup and wide loop functions. The programming of the Nodemcu module is just like the Arduino and Mega. In the white setup function, I activated the serial communication. 9600 is the baud rate. Then using the pin mode function, I set both the sensors to input. Sensor value 1 is a user-defined function, and this function is called every 1 second. Then starts the while loop function. Inside this function we have only blink.run and timer.run functions. As I said earlier, sensor value 1 is a user-defined function. This function has no return type and does not take any arguments as the input. Inside this function we are using if conditions to check which sensor is activated. I have already explained all of these instructions in my previous tutorials. I have a separate video on how to use the notification widget. This program is very simple. Still, if you have any questions, let me know in a comment. So that's all about the programming. I have already uploaded this program. Let's watch this project in action. Support me on Patreon for more videos. I hope you liked today's episode. Like and share this video with your friends. See you in next episode and thanks for watching.